Hello everyone, this is Sahiti, and today I'm going to talk about designing for failure and how to build a resilient system that can take failures. Let's start with a quick thought experiments. Imagine it's a busiest day like some Black Friday day if you're in retail, or month end close if you're in finance, or tax season if you're filing tax on April 15th or the last day. Suddenly, a critical part of your system goes offline. Customers are frustrated, maybe revenue stops flowing. This scenario isn't hypothetical, but it's the reality of the complex systems today. Things will fail, hardware breaks, networks get congested, software has bugs, dependencies become unavailable, humans make mistakes. So, for decades, our primary focus has been to make systems resilient to failure. So, we are trying to prevent failure at all costs. We aim for perfect uptime systems that never will go down. But here's the reality: preventing failures is impossible, especially as systems grow more complex and distributed. So, what if instead of trying to prevent failure, we design for it? So, what if we accepted failure as inevitable and build systems that could gracefully handle it? So, that's what we're going to talk about today: designing for failure. In the next 10 minutes, we'll explore why this mindset is crucial and at some of the core principles for building truly resilient systems. Okay, getting to the next slide. So, why design for failure? So, let's talk about that. Firstly, as I said, prevention of failure is a myth. Chasing 100% of time will only is a prevention tactics that leads to diminishing returns. It becomes exponentially harder and more complex and expensive to make systems up 100% of the time. Secondly, impact of failure in unprepared systems is often catastrophic. For example, a small glitch in one service can cascade and break down all the entire application. So think of something like a domino effect. So this leads to prolonged outages, terrible user experience, and significant business and customer impact. Designing for failure, on the other hand, aims to limit blast radius. It's about building systems that can withstand turbulence without fully collapsing, gracefully degrade functionality instead of completely failing, recover quickly when failures inevitably occur. It's not truly about giving up on stability, but achieving true reliability by acknowledging and planning for imperfection. So, moving on to what core principles and techniques we could use. So, let's talk about the core principles and techniques that we can use. So, this boils down to how do we actually do this? Now that we agreed that preparing for failure is a good idea, let's talk about what are the different ways we could do it and what works for your systems. On a high level, there are several key principles and patterns that you could follow. Let's touch on a few core ones. First is redundancy. So, this is one of the fundamental pillars. Never have a single point of failure for critical components. Run multiple instances of your services, databases, load balancers, ideally across different physical locations or availability zones. So, if one instance fails, the traffic can be routed to a healthier, redundant, or backup system. This is a simple concept, but it has a massive impact. Next is isolation. So, think of bulkheads on a ship. If one compartment floods, the bulkheads contain the water and prevent the entire ship from sinking. And similarly, in our distributed or complex systems that we are building, let's isolate components. A failure in a user profile service shouldn't bring down the entire payment processing service, for example. We can achieve this through techniques like assigning different resource pools for different parts of the service, following microservice architecture or queue based communication, and things of that sort. Next, let's talk about circuit breakers. Imagine calling a service that currently is overloaded or down, continuously hammering it to make things work for everyone and making it, in worst cases, unrecoverable. A circuit breaker pattern is used to address these kind of situations. For example, if certain failures reach a threshold, the breaker trips and it stops sending requests for a short period, returning an immediate error or fallback. This protects the calling service from wasting resources and also gives the failing service time to recover. After a timeout, it might let a few test requests go through to see before the system is deemed healthy again. So think of this as like a circuit breaker in electronics terms. Next is timeouts and retries. Don't let your service wait indefinitely for a response from another service. Implement aggressive timeouts. Even if a call times out, you might retry, but do it carefully. You can use techniques like exponential back off and limited number of retries. Otherwise, you can accidentally create a retry storm that intensifies the request to an extent that instead of solving the problem, it creates a new problem. Okay, next, let's talk about graceful degradation. Sometimes offering partial functionality is much better than offering nothing. If a non-critical feature falls, like for example, displaying some news articles on a news site, can the core functionality like reading the main article still work? Or design your systems keeping this in mind. Try to make your core functionality separate from the non-critical functionality so that if non-critical ones fail, it doesn't affect the core functionality. And next we talk about, now that we have discussed various strategies, now coming to the monitoring and observability aspect, which is an absolute must into understanding your system's health. So it add robust logging, metrics, failure detection, understanding the impact, diagnose the root cause, and verify that your resilience methods are working as expected. So you can't really manage what you can't measure. So it will be both helpful in recovering from a failure as well as doing a root cause analysis once your failure has been recovered so that you can prevent it from happening again. So monitoring is one of the most important things that you would should definitely add to your system. Alright. Now let's move on to the next slide. Now that we understood what are the different ways you can make your system resilient towards a failure, let's just try to see how to shift your mindset, because we are entirely shifting from a prevention of error to making sure your system actually works when an error comes. Let's just talk about that. Implementing these patterns is not just about code, it's about a cultural and architectural and mindset shift. It means developers, testers, operation teams, SREs should be constantly asking, what happens if this part that I'm working on fails? How will the system behave? How can we contain the impact? So it encourages practices like chaos engineering intentionally. We should encourage practices like chaos engineering, where you intentionally inject controlled failures into production environments to test how the system actually responds and uncovers weakness before they actually cause real outages. So it's about proactively validating your resilience. For moving to the next slide, concluding, I would to talk about failures in our complex systems, especially distributed systems or machine learning, engineering included systems, isn't an if but when. Or trying to prevent every single failure is a losing battle. So by embracing the designing for failure mindset and implementing patterns like redundancy, isolation, circuit breakers, graceful degradation, and timeouts and retries, all supported by strong monitoring and observability, we can build systems that are truly resilient, systems that handle failures gracefully, minimize user impact, and recover quickly. This leads to higher availability, better customer trust, and ultimately more successful product. Go back to your teams and start asking this question: what happens if this fails? Start small, pick one critical component and analyze its failure modes. Introduce one resilience pattern. Build that muscle, expect failure. Test it out by injecting the failure, design for it, and build resilience. Alright, that's all I have. Thank you. Let me know if you have any questions or you can contact me.